Hello, testing, testing, probando, probando, uno, dos. Can
Good
you
morning,
hear?
mister.
Good morning, guys. I hope you're doing well. Just hold on a second. I'm going to change the camera view. Yeah, better. And I'm not sure if I pin my video. Let's see. Yeah. Oh, yeah, that's right. Okay. Today we're going to continue uh, solving system equations of two variables, but applying the following techniques. Just hold on a second. Let me looking for the textbook I'm going to use in a few examples. Hold on, hold on, hold on. Yep. Okay, so today we're going to continue with solving our system of equations into variables. All right. Okay. In the last class, we learned how to solve the system equations into variables applying the substitution and elimination method. Now, we're going to learn how to solve the following system equations using the graphical technique or the graph method. For this example, use the graph method to solve the following system of linear equations. All right. So by the way, guys, can you see perfectly well the whiteboard? All right then. So the system will be 2x plus y, 2x plus y equals 1. And the second one will be 3x plus 4y will be equal 14. Okay. So remember in the last class, we were talking about according to how many methods and how many kinds of system or linear equations do we have. For example, I have a question over here. Yeah, don't worry, Adrian. Well, so remember, we have three kinds of system or linear equations. In this case, two variables. The first one, the first one we're talking about a consistent system of linear equations. We're talking about consistent because we're going to have one solution set. I mean, an answer for X and an answer for Y. We have the second kind that's supposed to be the dependent system equations. In that situation, we're going to have infinite solutions, and you're going to find out that situation because we're going to have an answer like 0 equals 0, 1 equals 1, 20 equals 20. And when happens that case, okay, this is going to be dependent system equations, all right? And finally, we have the inconsistent system equations in simplementary words. And that system means there is not going to be a solution set in of the problem. Now, we're going to learn how to solve this system equation two variables by the graphical method. The first thing that you have to do in both cases, I mean, into the first one and the second one equation, you have to write equation in the slope intercept form. Simple English, you have to solve for y in both equations. Meaning, for example, we're going to take the first equation, 2x plus y equals 1, and we have to solve for y. Remember, at the moment we're going to solve for y, we have to write this expression in canonical order. I mean, the first term that will be x, and the second one, the number. So 2x is adding, passes to subtracting. For that reason, y will be equal negative 2x plus y. Okay, this is going to be the first step. In the second step, what we have to do, because this is a graphical technique or graph method, we have to remember we have two ways we can sketch the graph of this equation. One of them is creating a table values and plotting points, and the second one will be by interceptions, the x and y intercept. It doesn't matter what technique you're supposed to use. At the end, we're going to have the graph. Well, in my case, because I really want to create a quickly graph, we're going to find out the interceptions. Remember, what is the mean interceptions? For example, what will be the value from x when y has a zero value? Well, simple. We're going to take this equation, replace those values. 0 equals negative 2x plus 1. This is subtracting, passes to adding. 2x equals 1. And the number 2 is multiplying, passes to divide. Okay? And we have the first interception point. What is the value from x when y equals 0? Simple. The answer will be 1/2. And now the opposite. What could be the value from y when x equals 0? What does that mean? Okay, I have the original equation, y equals negative 2x plus 1, and I'm going to replace the letter x by 0. So negative 2 times 0 plus 1. So we can conclude y equals 1. Okay, so the interception point of the first equation will be given by 1/2 comma 0, and at the same time 0 with 1. Questions to this one? Questions or everything's clear? Guys, clear?
Everything's clear.
All right then. Now, this is going to be the first step. Second step, we're going to take the second equation. I'm going to use a green one just for, we have different colors, and we're going to apply the same factors. I mean, 3x plus 4y equals 14. And remember, we have to try to solving for y, just like in the first equation. And writing this expression in canonical order. I mean, 4y will be given equals next negative 3x plus 14. And because the number 4 is multiplying, it passes to divide. Divide what? Both numbers. I mean, negative 3 4x plus 14 over 4. And because 14 over 4, both numbers are even numbers, actually, to tell you the truth, well, simple, we can simplify them. You know, half of 14 will be 12, and 7, sorry, and half of 4 will be 2. So this equation will be given by negative 3 4x plus 7/2. Okay, we have the second equation. Okay, written in the y into slope intercept form, or solving for y. And we're going to repeat the process. Interceptions or plotting points. If we want to use interception, remember, we have to find out what will be the value from x when y equals 0. What does that mean? I'm going to change the letter y by 0. 0 equals negative 3 4x plus 7/2. I mean, negative 3 4 is subtracting, passes to adding. 3, 4x equals 7/2. And 3, 4 is multiplying, passes to divide. So we're going to divide 7/2 divided by 3, 4. So give me a hint. What will be the answer to divide 7/2 divided by 3, 4? Somebody?
For 2/3.
In fractions, in fractions, in fractions.
Um,
14/3.
14 over?
3.
Okay. 14 over 3. Okay. So we have the first intersection point. When y equals 0, x that will be equal to 14 over 3. Now, what will be the next step? The opposite. What's supposed to be the value from y when x that will be given by 0. Well, simple matter words, you can copy the equation once again. Y equals negative 3, 4 x plus 7/2, and that will be given by negative 3, 4 times 0 plus 7/2. So y will be given by 7/2. And we got the second interception points will be the first one, 14 third 0, and another one will be a 0 with 7/2. Okay, remember to solve this equation by graphical method, first step, solve for y in both equations. Second step, find the interceptions, or if you wish, create a table values to obtain the plotting points and sketch the graph, because this is going to be the third step. We have to sketch the graph in the of both equations. I don't know if did you copy that already, guys, or not yet.
already copied, Mister.
Okay, then. So what is basically the most important thing in this method? Well, the most important thing in this method, you must use the ruler. Get right measures, because if you obtain right measures, there's not gonna be any problem at the moment to write an answer, because the graph will tell us what is the interception point, and that interception point means the solution set of the problem. Okay, so let's see. Actually, give me a hand. What is the decimal value of 14 over 3? Valor en decimales.
4.6 or 4.6.
4.66666 or only 4.6?
No, see,
Okay,
4.66666.
we went around 4.7. Okay, well, let's going to sketch the graph. Okay, let's create the coordinate plane with right measures. If you have, that's why at the moment going to request your notebooks, that's supposed to be using this little square, because it's useful at the moment to create a measures. 1, 2, 3, 4, 5, 6. 6 units, that will be enough. 1, 2, 3, 4, 5, 6 units. We can cut it this one. 2, 3, 4, 5, 6 units. And 1, 2, 3, 4, 5, 6 units. All right. This is y, negative y, x, and negative x. Okay. Remember, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 2, 3, 4, 5, -6, 1, 2, 3, 4, 5, and 6. Okay, remember, what we're going to do in this case? We're going to sketch both graphs. Remember, the first one, I mean, the purple one, the interception point will be 1/2 with 0 and 0 with 1. Okay. And was purple one, 1/2 with 0. Remember, 1/2, that will be approaches over here, 0.5. And another one will be 0 with 1. And remember, according for the geometry definition, we require at least 2 points to define a line. Okay, so it doesn't matter, actually, it doesn't matter if this line overpasses the 2 points, even though if you are creating a greater line, that will be nice or better, all right? And I'm using the purple one because that's supposed to be the color of the line. And if you wish, you can label this equation using the expression y equals negative 2x plus 1, okay? And we have the first graph. Now the second graph. Remember the second graph, the interception point that was 4.7 with 0. Okay, approaches over here, okay? 4.7 with 0. And another one, 0 with 7/2. You know, 7/2, we were talking about 3.5. So the green point will be located between the number 3 and the number 4. Okay, and now let's going to sketch the graph. Remember, it doesn't matter if this line overpasses the mark. I'm going to create a little bit longer, the purple one. I'm going to create a little bit longer, this purple line. Da, 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 da. Okay, and we have the graph, okay? But what is the big deal to obtain this two graph? Remember, I explained the last class, explained you already. We have 3 kinds of system equation to variables: consistent, inconsistent, and dependent. Consistent when we have a solution set. I mean, one answer for X and one answer for Y. Inconsistent, there is no solution. And dependent, even though we have 2 equations, the answer always will be, for example, 0 equals 0, 2 equals 2, 10 equals 10, and so on. And the graph, what's supposed to be the pattern? If you check your notes, inconsistent, we have 2 parallel lines. Consistent, we have an intersection point. Independent, even though we have 2 equations, we're going to obtain one singular graph, right? So can you see perfectly well in the whiteboard? Obviously, this is going to be a consistent system, right? Because we have a collision. And what will be that collision? If we see carefully in that situation, the intersection point will be located over here, right? Between these 2 lines, okay? So would you like to tell me, I don't know if it's over there in home, can you appreciate that equation? Or if you wish, can I remarkable that expression? So would you like to tell me what will be that intersection point between this, the red, the purple and green one line? Can you see that well or not?
No, negative
Mhm.
3, 6.
Exactly. X will be equal to -3, and 6 will be y, right? So because there was the interception point, the only thing that you have to do in this case says, okay, the solution set will be given by -3 with 6. And that's it. That's all that we have to do. In this case, you don't need to um, solving for X or solving for Y. No, you don't need to do the steps like that. So the only thing that we have to do is create the equation. Once again, we have to solve for Y in both equations, okay? And after you solve for Y in both equations, the next step that's supposed to be create all table values or interception points. I'm using interception points because it's an easy way how to obtain that the graph. But if you want to create a table values, it's up to you. At the end, the purpose is create the both lines. And after you graph the both lines, you shall see what it is the interception point. Okay, and that's it. Questions or everything is clear?
Everything's clear, Mr. But in this answer, we need to. Well, no, everything's clear.
Yeah, the problem ends over there. So guys, questions to this part or everything's clear? María José, Diego, eh, did you understand? All right, so let's going to solve another example. Okie dokie. I'm going to erase the first part of the whiteboard. Hold on, hold on. Let me change the camera view. And basically, you don't need to solve for X or solve for Y. Okay, sorry. Solve for X or solve for Y. No, 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 no. We have to create interception points between them. All right. Let me erase this problem and let's going to proceed to another example using the graphical technique. It sometimes turns out a little bit tedious in this sometimes because you're going to see we have to find out the intercepts or create the table values, but at the end the answer will be given by the interception points. There is no mathematical calculus that you have to do it. Okay, we have another example, same instructions. I'm going to add example number 2 and instructions defined like 3x plus 2y equals 14. Okay, 3x plus 2y equals 14. And another one will be x minus 2y that will be equal to, obviously, the number 2. Okay, so what we have to do, we're going to apply the same steps. I mean, remember, we have to take the both equations and solve for y. Okay, taking the equation number 1, 3x plus 2y equals 14. Okay, now we have to solve for y. 2y equals negative 3x plus 14. And because we're looking for the value from y, that will be given by negative 3.5 x plus 7. Remember, this number 2 is multiplying, passes to divide. Divide what? Both numbers. You can leave the equation using this fraction, negative 3.5, or if you wish, you can write like a negative 1.5. At the end, the result will be the same. Okay? Now, let's find out the interception, x and y intercepts. Or if you wish, you can create a table values. It doesn't matter, okay? Well, in interception points, remember, we have two questions. What will be the value from y? sorry, the value from x when y equals 0. Remember, at the moment y has a value from 0, remember, 0 equals negative 3.5 x plus 7. 3.5 x equals 7. So x will be 14 over 3, okay? And 14 over 3 in decimal numbers, give me a hand, will be 14 over 3 in decimal numbers. 4.6, okay, 4.7. 4.7. Now, the opposite was supposed to be the value from y at the moment when x, that will be equal 0. You know, negative 3.5 and 0, 0 plus 7 will be 7. And we have the intercepts, giving a mini table values. We can represent it this way, or if you wish, we can write the interception point just like this one, 4.7 with 0 and 0 with 7, okay? That will be the first equation. Well, now let's going to take the second one. X minus 2y equals 2, okay? Same happen. X is adding because it's positive, passes to another side to be negative. Will be negative 2y equals negative x plus 2. And that negative 2 is multiplying, passes to divide. What does that mean? That means the value from y will be given by positive 1/2 x because positive, because negative times negative is positive. And next to the letter x, we have a number one imaginary number. So for that reason will be 1/2 x. And positive 2 divided by negative 2 will be given by negative 1. And we have the second equation. And same happen. Let's do it again, the same steps. I mean, x and y. For example, what will be the value from x when y equals 0? Well, simple. 0 equals 1/2 x negative 1. Negative 1/2 x equals negative 1. X equals negative 1 over negative 1/2. For that reason, x that's supposed to have a value of 2, right? Oof. And another one, what will be the value from y when x equals 0? Well, 0 and x, y will be given by negative 1. And we can perfectly write these interception points using 2, 0, 2, 0, and another one will be 0 with negative 1. Okay? As soon as you can see, same technique, same method, taking the first equation, solving for y, interception point. Taking the second equation, solving for y, interception point. What will be the next step? Obviously, create the coordinate plane and graph those interception points. Sorry, it's I'm having hard time to breathe with this mask. So complicated, that one. Okay, question, did you copy that already or not yet? Okay, excellent. I'm going to move the camera to the right side. And the only thing that I'm going to erase will be the lines because I don't want to create once again the coordinate plane. But, you know. Al estilo hondureño, un poquito chambón, por no querer trabajar doble. Pero lo importante es el plan. Remember, Remember, guys, we have to use the ruler and take right measures. All right. This is number 1, 2, 3, 4, 5, 6. And we're supposed to have 7 units. Why? Okay. I'm going to increase the lines over here. 7. And this is going to be y. And we are fully prepared. Well, remember, the first line, we're supposed to graph 4.7 with 0. 4.7 approaches over here. Approaches. And the second interception point will be 0 with 7. Okay? And now we can connect both points, these 2 points. Okay? It doesn't matter if it overpasses the 2 lines. Actually, even though you're creating a bigger lines, will be better. All right. So this is going to be the first line. And if you wish, you can label a line like y equals negative 1/3 x plus 7. This is going to be the first line. Okay. Now the second line, remember the intersection points of the green one, that will be 2 with 0, okay? 2 with 0. And another one will be 0 with negative 1 over here. And now let's going to graph this equation. And this is corresponding, hold on. Yeah, this is corresponding to the line y equals 1/2 x minus 1. Okay. What kind of equation is this one? Consistent, inconsistent, or dependent? Consistent, inconsistent, or dependent?
Consistent.
Consistent, because we have an intersection point, right? So would you like to identify, obviously, the intersection point will be located in this situation, right? I'm not sure if you require zoom for this graph, and I'll do it right now. And would you like to tell me what will be that solution set or the intersection point between these 2 lines?
For 1.
Exactly. 4 in x and y in 1 in y-axis. I mean, that solution set is 4 with 1. And that's it. That's all that we have to do in this system of equation to variables using the graphical technique. ¿Preguntas, muchachos? ¿Todo bien? ¿Todo azul?
No, I don't have questions
Yeah.
for this one.
Okay, and the rest of the people located over here, questions? No? Did you understand?
But we can still, but we can still solve the question that we solve in these exercises, like in other methods, right?
In other methods, it doesn't matter what kind of method you're going to use, guys. The result will be the same. Okay. Just hold on. Yeah, just well, hold on a second, guys. Hold on. Misu, hold on. Okay, guys. Tomorrow, you got wheels. We're going to continue solving another example. What happens if we have inconsistent and dependent system equations using the graphical technique? Okay. Today we're going to finish the lesson to this part, and you got wheels. Tomorrow continue. Right? You are dismissed.
Bye, Mister.
Hi, Mr.
Bye bye. Take
Mister,
care
I
of
have a
yourself.
question.
Have a Tell me, Sophia.
I'm Manuel, Mister.
Oh, sorry.
El 29, Mister, ¿cómo van a hacer dice que van a hacer manifestaciones, ¿cómo hacer, Mister?
Lo más seguro, si hay manifestaciones el 29, lo más seguro que las clases se den en online. De eso no creo que haya algún problema.
No, es que mi su aquí mandó y dice clase vía Zoom, depende de la situación política.
Yeah, it depends the situation because that's supposed to be the half of the students that's supposed to be in this institution, and in the other hand, that's supposed to be at home, right? But if you're studying at home, there is no problem. You're still receive the classes by via Zoom, right? So don't worry
Okay.
about it.
Okay, Mister.
Okay, have a great and wonderful day. Take care of yourself.